Okay, so our first example of how we're going to solve an equation using some of this information that we've just recapped. So we've got an example here where the left-hand side of our equation, 2 to the power of x, is expressed as a base with an exponent. But the right-hand side is not, it's just expressed as a normal number. So the first thing that we're going to do is express them both as a base with an exponent. Okay, so this is where that root power knowledge is going to come into play. We need to look at 32 and we need to make the base of 32 the same as the left-hand side. So I know my base is going to be 2 and I have to think, okay, what exponent of 2 is going to turn this into 32? So you should know from recall that 2 to the power of 5 is what gets you to 32. So I've kept the left-hand side the same. All I have changed is the right-hand side because 32 is the same as 2 to the power of 5. Okay. Now here, because, make a little note of this, because our bases are the same, our exponents must also be equal. Okay. And because of that, what that allows us to do is to now remove the base and just be left with x is equal to 5. So we have solved that by simply changing the base so that they are the same. If they both have base 2, then x must be the same as 5. Okay, so that's a simple version, or the first way that we can start to build our knowledge of requiring this base change. Now we'll look at example 2. Okay. And the idea is exactly the same. Okay. On the left-hand side, we have something expressed as a base and an exponent. And on the right-hand side, we have something expressed as a normal number. So again, you're going to change those bases, or the base of the right-hand side, so that it is 3. If we change 81 to be base 3, again, that knowledge needs to be with us. Okay, 3 to the power of what is 81? And that's going to be 4. It needs to be an exponent. Okay, so that's going to be 4. Okay. Then, again, I'm going to copy this over here. Because our bases are the same, our exponents must also be equal. Therefore, x2, our exponent on the left-hand side, must be equal to 4, which is our exponent on the right-hand side. Okay. And then in this case, we haven't quite finished solving. We just need to take away that 2 from both sides to solve it completely. Finish off. So all we did there was just a little minus 2. Took away 2 from both sides so that we are left with x being equal to 2. Okay. So this is a standard version, or the first way we can solve equations requiring a change of base. So you can pause this video, go forwards and backwards. I now want you to give this set of questions a go, please. So in your book, you can write these down, have a go at these, pause the video here, or rewind if you need to watch those examples again. You can go and do that now for me, please. And then come back in when you've finished, and the answers will come up in a moment. Okay, answers. So you should have hopefully worked through those and been able to go back and have a look at the examples again if you need to. Your answers to those should be there, so you can now mark those, photograph the work that you've done, and just pop a quick picture of that into the Google Doc so I can see what you've done there for me, please. Awesome. On to the next one.